Hey guys, I want to talk about addressing for a moment. If you have a computer connected to a switch, another computer, and they're connected to a router, which is connected to another switch, and you have a couple computers over here. I'll put the letter C for computers. I want to emphasize the fact that as traffic moves from here to here on the LAN, in the local area network, that it's the Ethernet header addressing. If this is an Ethernet frame, then it's the header's source destination address inside here, and the source address of the Ethernet frame that are being seen in the local area network. Okay, definitely inside this data field, and there's a data field inside the Ethernet frame. The IP packet is hidden inside of there. Okay, so that's known as data from the Ethernet frame's perspective, and even from the Ethernet switch. When this Ethernet frame goes through this switch and goes out whatever port it goes out, it's the Ethernet header that is what is causing it to get, I won't say routed, but I'll say switched. The switch looks in its bridge table, its MAC table, otherwise known as CAM table, and it's the MAC address that decides where it's going to go, the destination, all right? When this Ethernet frame arrives at this router, the Ethernet frame is decapsulated. This trailer, which is a cyclic redundancy check, otherwise known as a frame check sequence, that's a trailer to see if the packet has taken an error. So the trailer is destroyed, the header is destroyed. In the Ethernet frame, that's when it gets to an IP router. So that's gone. It's no longer an Ethernet frame as it gets decapsulated at the router. Now the router sees what used to be data at layer 2 in the Ethernet LAN is now being seen in its original state as an IP packet. Okay? And now the header is seen. Now we see source IP address and destination IP address inside of here. That's what the router is seeing. It came from this IP address here, and it needs to go, let's say for instance, it needs to go to this IP address over here. So the Ethernet frame only survives as long as the Ethernet LAN reaches. So if the Ethernet LAN stops here, if it stops at these computers there, that's where the Ethernet frame exists. This is otherwise known as a bridge domain. It's otherwise known as a broadcast domain. It is not known as a collision domain. I've talked about that in another video. Collision domains are things that don't really exist anymore, really because of full duplex Ethernet, that each connection on an Ethernet switch is its own collision domain, sort of. But anyway, collision domains are kind of a thing of the past, and I even speak to that in another video. This is a broadcast domain, and it can be an administratively defined broadcast domain, otherwise known as a VLAN. So anyway, let's just think of this as if it's one VLAN right now, and we're talking about the mechanics of a VLAN. So that Ethernet frame only survives from computer to router. It's decapsulated, it becomes an IP packet. The router decides to route that packet across its backplane and onto this subnet on its way to the intended destination. So as it exits this router on this interface, it then gets re-encapsulated into another Ethernet frame. This data packet goes, or this IP packet goes back into the data field of an Ethernet header with a new destination I'll say DMAC, destination MAC address. Earlier, I think I said destination address, but you should know it was a destination MAC address. Also the source MAC address. And so, by the way, just backtrack a little bit. The destination MAC address is in fact the interface of the router when it's going across the LAN. As it exits the router, the source MAC address is now the router. The destination MAC address across this LAN is the intended Ethernet endpoint here. So again, you have Ethernet in the LAN here that exists from edge to edge in the Ethernet broadcast domain, and the source MAC address again is the router. The IP packet gets re-encapsulated, and it gets sent to the destination MAC address of the computer, which, as it arrives, gets decapsulated. Throw away the trailer, throw away the header, then the IP packet arrives at the computer. And so, in seeing this, I'd like you to realize that the original IP packet it remains intact the whole way through. Okay? So, something to understand about this is you have in layers of the communications model, the two computers that were communicating have layer 2 addressing that arrives at the router, and then another layer 2 domain exists from here to here. You have at layer 3 IP addressing that actually flows across the router and arrives here. The router just simply gets that IP packet and forwards it across. Now, something I didn't mention previously, but within the IP, so let's just look at it like this. You have the Ethernet frame, and in the data field is the IP packet of the Ethernet frame. In the data field of the IP packet is a TCP or UDP port number. I bring that up real quick to show you that the app that, I'll draw it as a little cloud in here, and I've kind of spoke to this in previous videos, but the app that is residing inside the application, client to client or peer to peer or client server application, whatever it is, this app has a layer 4 address. And so here again, you have layer 4 addressing, which is known as ports. It's a 16-bit port number. It's because the finite field of the UDP and TCP, UDP or TCP header that's inside of the data field of the IP packet only allows for, it's a 16-bit field, and so the port number can be anything from 0 to 535. So that's 2 to the 16th power. All right, so I just wanted to present that layer 2 domains exist where we talked about in here. Layer 3 domains are global in nature. They can go, you can keep the same IP packet addressing from United States over to the other side of the world. I mean, it's end to end. If it doesn't go through, some network address translator, if it's truly publicly routable addresses, they can stay intact and be routed across the whole planet. And then layer 4 also is end to end. All right. So hope this is helpful. And I look forward to the next video with you all.